Special right triangles. So there's two types of special right triangles that we have. All right, our first special right triangle is called a 30, 60, 90 right triangle. Okay, so this has to do with 30 degrees, 60 degrees, and 90-degree right triangle. And what makes them so special is the fact that they always keep the same ratio. The side lengths keep the same ratio. So if this is a unit circle, meaning the radius is 1 degree, 1 unit long, 1 meter, 1 foot, whatever, just 1 unit long. All right. So if this radius is 1, okay, and this angle here is a 30-degree angle, so I'm measuring from my radius out. You can see that this angle here is a 30-degree angle. So that's my 30 in here. These three side lengths will keep the same ratio. This unit, this hypotenuse, is my radius. This will be 1. The leg that's opposite the hypotenuse, this will always be half of the hypotenuse. So in this case, since this is 1, this is going to be 1/2. And then my third leg here, which is going to be the leg that's opposite the 60-degree angle, so I'm going to take the 60 and I'm going to put it in here. So the leg that's opposite the 60-degree angle, this is going to be the ratio or the numerical value of radical 3 over 2 as the exact value. Now we could turn that into a decimal, but we're going to leave it into radical values. Okay, so the triangle, this 30, 60 degree, 30, 60, 90 triangle will look like this. All right, so these are the general form of this triangle, general formula in a sense. So if this is my hypotenuse, opposite the 90 is the hypotenuse, this will always be x units long. The leg that's opposite the 30 degree will always be half of the hypotenuse, so 1/2 times x, whatever the hypotenuse is. And then the leg that's opposite the 60-degree angle, this will be x times radical 3 over 2. And again, it will always be in that ratio if this is a 30, 60, 90 triangle. Our next triangle here is our 45-degree, 45-degree, 90-degree triangle. Okay, so you notice this is my radius here. This is a unit of 1. These two angles here are my 45-degree angles. Now, because these are both 45-degree angles, then that means this triangle happens to be an isosceles triangle, which means that this leg is congruent to this leg. This is my radius of 1. This is my radius of 1. And this hypotenuse here will be the square root of 2. And we can find that easily with the Pythagorean theorem if you wanted to. So this will always be in that ratio of 1, 1 radical 2. All right, so looking at the formula for this one. So this leg is x, this leg is x, this leg will be x radical 2. So hypothetically, if I told you x was 10, this leg will be 10, this leg will be 10, and then this leg will be 10 radical 2. Alright, so now let's use this information and try to solve some problems. Here's our first problem. Here's a 45-degree triangle, 45, 45, 90. It tells me that this is 45, so by default this has to be 45 as well. That means this leg has to be congruent to this leg. Okay, so I'm just going to draw these out for myself until I memorize these. I'm going to say, okay, this is my x, this is my x, and this is my x radical 2. What are they giving me? They gave me this leg here. So they already told me that this leg is my x, so I know that x is going to be 7. This piece here, and I'm referring to this x here. So let's just change these variables to a and b just to not mix up x and y here. So if this is my x here, 7, so that means my b is also going to be congruent to this, so b here is going to be 7. So this is going to be 7 because those two legs are identical. That means a here is going to be x times radical 2. Well, do I know what x is equal to? X is equal to 7, so this a here is going to be 7 radical 2. Now I think the 45, 45, 90 is a little easier than the 30, 60, 90 just because two of the legs are the same, but let's try another one as well. So here's our next one. And again, I'm just going to write this down for myself. I'll say this is my 30-degree angle, so this is going to be my hypotenuse is x units long. My leg opposite the 30 is going to be 1/2 of the hypotenuse. And the leg opposite the 60 is going to be x times radical 3 over 2. So what are they giving me here? Okay, so they're giving me my hypotenuse. So my hypotenuse is 2, so that means my x is equal to 2 in my triangle. Well, now that I know this, well then I know the leg opposite the 30-degree angle, which is in this case is going to be b. B is going to be 1/2 of x. Do I know what x equals? We just found out that x equals 2, so this is going to be 1/2 of 2. In this case will just be equal to 1. So B here equals 1. And then A, and A here, A is my opposite my 60. So A is equal to x times radical 3 over 2. We know x is equal to 2, so I'm just going to plug in for 2 here. So I have 2 times radical 3 over 2. Simplify. Your 2 simplify, and you're just left with radical 3. So A here is equal to radical 3. Alright, so my next triangle, I have again another 30-60 triangle. I have my 60 degree here. Here's my 30. I'm just going to draw that side triangle for myself so that I know this is going to be x. This would be my 30 degree angle here. So this would be 1/2 of x. This would be my 60 here. So this would be x times radical 3 over 2. Okay. So notice what they gave me so far. So far they gave me the leg that's opposite the 60. Okay, my goal here is to solve for x. So they said that this leg here, radical 6 over 2, is going to equals x radical 3 over 2. That's that piece here. So I'm going to set this leg here, opposite the 30, equal to this formula, or just general formula here. And I'm doing this so I can solve for x. So I'm going to say that x times radical 3 over 2 is equal to radical 6 over 2. And I want to solve for x. So how do I get rid of the coefficient in front of x here? I have a fraction. How do I get rid of this? I can multiply by its reciprocal, which is times 2 over radical 3. And I'm going to do that to both sides, times 2 over radical 3. Here my reciprocal simplifies, so I'll just get x equals. And what simplifies here? My 2 simplify, and then I have radical 6 over radical 3, which is simply going to equal radical 2. So now that I know what x is equal to, that means I know what my hypotenuse is equal to, because my hypotenuse is equal to x. So that means b is equal to radical 2. And now if I know my hypotenuse and I know what x is, then I know what the leg opposite of 30 is, because the 30 is going to be half of the hypotenuse. So this will just be radical 2 over 2, half of it. Alright, so here's my 45 degree triangle. So this is 45 as well. And remember, since both these angles are 45, then n and m have to be equal to one another because they're isosceles triangles. Alright, so I'm just going to draw my 45 degree general formula here. So this is x, and this is going to be x radical 2. So they're telling me what the hypotenuse is. So it's giving me the hypotenuse is equal to 10. So this 10, to solve for x, I'm going to set it equal to that formula there. So this is going to be 10 equals x radical 2. To solve for x, I'm going to divide both of these by radical 2. That simplifies, so I have 10 x equals 10 over radical 2. I'm going to simplify this. So I'm going to multiply both numerator and denominator by radical 2. So in here I get 10 radical 2 over 2. Simplify it one more time, and this simply just equals 5 radical 2. So x equals 5 radical 2. That's my m. And since n and n are the same, then this is also going to be 5 radical 2. So here I have two triangles put next to each other. My first triangle is a 45, 45, 90. My second triangle is a 90, 60, or 30, 60, 90. Okay? They gave me information on my 45 triangle. So that's where I'm going to start first. I'm going to start in this triangle first here. So they gave me that this is my 45, this is my 45. So that means I know what x is, right? Based on my formula here, this is my x, this is my x, and this is my x radical 2 on my 45 degree triangles. So here's 7 radical 2, here's 7 radical 2. So that means I know what x is, so I need to find this length here of this line segment. So I'm looking for this guy here. So now I have x, and this piece here is x radical 2. So I'm going to plug in 7 radical 2 here in for x. So I'm just going to do the math here on the side. So 7 radical 2 times radical 2. And this would just be 7 times radical 4, or 7 times 2, which is equal to 14. So this whole length here is equal to 14 units long. Now I have parts of my 30, 60, 90 triangle. Okay? I have the leg opposite the 60 triangle. So if I want to just draw my triangle here for a second. So if this is my 90, let's say this is my 30. Here's my 1/2 x. Here's x. Here's radical 3 over 2x. I'm telling you that this leg here, opposite to 60, is equal to 14 units. Okay, so how do I get 14 units? How do I get x out of 14 units? I had to multiply this by, had to multiply radical 3 over 2 by something to get 14. So what is that something? So let's set 14 equal to radical 3 over 2 times x. So I can figure out x. Once I figure out x, then I know what my hypotenuse is. And then I know what my other leg is, which is going to be half of the hypotenuse. So how do I multiply this? Multiply this through by its reciprocal, so 2 over radical 3 times 2 over radical 3. These will simplify, so I have x equals 28 over radical 3. I don't want to leave it this way. Multiply both numerator and denominator by radical 3. So this simply becomes 28 radical 3 over 3. Check to make sure you can't simplify again. So 28 over 3. 3 doesn't go into there evenly. So your final answer is 28 radical 3. So this is going to be 28 radical 3 over 3.